first look at how to convert numbers to from mixed numbers to improper fractions. So I think we looked at some problems last time, like 5 1/2. And if you recall, you take the number on the bottom, the 2, you multiply it by the 5, and then you add the top number. So see the bottom number times the number in front, and then you add the top number. So what is 2 times 5?
15.
Try again. 2 times 5, it's less than 15?
Oh, wait, 10.
10. Yeah, and if you have a multiplication table, please have it out, or if you want me to provide you one, I can. I say this. That's 10 plus 1. What is 10 plus 1?
11.
11. And then what number goes in the bottom? Do you remember from last time?
The 1.
It's the bottom number. It's the same bottom number.
Oh,
it's always the same. Yeah. Whatever's on the bottom stays on the bottom. Okay. Now let's say similarly, we wanted to look at something. Let's look at a new problem here. Do you have this down in your notes?
Yes.
Let me know when you get this down. Do you have this down?
Yes.
Okay, so let's look at a new problem here. So same thing here. Let's say it's 3 4/5. Okay, 3 4/5. So you're going to take that bottom number, that 5, and what are you going to multiply it by?
The 3.
The 3, yeah. And which number do you add?
The 4.
The 4. Very good. Okay. What is 5 times 3?
13.
Okay, plus 4?
19.
19. And what number goes on the bottom?
The 3. No, the 5.
It's the same fraction, whatever. Let's go back and look at the previous problem. What number went on the bottom?
The 2.
The 2. It's always the bottom number. Whatever's on the bottom stays on the bottom. Is that okay? Is that clear?
Yes.
All right. So the 5 comes down to the bottom. Do you see that?
Yes.
Okay. So there's two parts. There's the top, and then there's the bottom. You get the top by taking this bottom number, multiplying by the number in front, and then adding the top number. Okay, you ready to try one on your own here?
Yeah, yes.
All right, let's go at 2 4/7. 2 4/7. So I want you to tell me the improper fraction, please.
Okay.
Let me know when you have your final answer.
I'm done.
Okay, what is your final answer?
I got 18/7.
18/7. Is that right?
Yes.
Very good. Well done. Okay, so here's why we're learning to do this, because we want to be able to take numbers like the following, 2 3/4, and subtract 1 1/4. Okay, so these are both considered what are called mixed numbers. And the reason they're called mixed numbers is because they have a whole number and then they have a fraction. So it's the idea is you're mixing a whole number and a fraction. Okay, so you as the math student have to be able to convert both of these to improper fractions. You have to be able to take that 4, multiply it by the 2. What is 4 times 2?
4 times 2 is 8.
Okay, and then you're going to add the 3 to it. What's 8 plus 3?
11.
11. And then what number goes on the bottom?
4.
The 4. Minus, and we've got to do the same thing here. 4 times 1 plus 1. 4 times 1 plus 1. What is the result of 4 times 1 plus 1?
5.
5. And what number goes on the bottom?
The 4.
Very good. Okay. So now can you subtract these fractions the way they are? Do you know if that's okay? And it's based on the bottom number here.
Yes.
Because the bottom number is the same, you can subtract them. What is 11 minus 5?
6.
6. So this becomes 6 over 4.
Yes.
Good. Okay. So again, the steps are when you have two mixed numbers, you have to convert them to these improper fractions. Okay. And then you subtract and then divide. All right. Now there's a bit more to do here, but we're going to keep doing examples so that you can learn this even better. Let's go 2 and 5/6 minus 1 and 4/6. Okay. So I want you to convert each of these into an improper fraction, please. When you have either of those, please let me know what you have as a result.
Okay, I got it.
What is the one on the left? Give me the fraction on the left.
16/6.
Okay, so 6 times 2, 6 times 2 is 12, and then you have to add the 5 to it. What is 12 plus 5? It's not 16. You're really close.
17.
12 plus 5. So you're basically counting up from 12 5 spaces. So like 12, 13, 14, 15, 16, 17. So plus 1, plus 2, plus 3, plus 4, plus 5. Okay, and what number goes in the bottom?
The 6.
6, good. How about the other one? What is 6 times 1 plus the 4?
25.
6 times 1. You're taking
Oh.
6 times 1. Yeah.
6. 10.
Okay. It's 6 plus the 4 is 10. What number goes on the bottom?
The 6.
The 6. Good. Okay. Now, why are you allowed to subtract these fractions? What is it?
They both have the same denominator.
That's right. What is the numerator? What is 17 minus 10?
7.
7. Good. Okay, we got to work. We got to get better. We got to get better at converting these mixed numbers. Okay, so let me just throw some multiplication facts at you. What is like 3 times 5?
15.
15. Okay, and let's say I want you to add 4 to it. What is 15 plus 4?
19.
Good. How about 6 times 7
42,
plus 6? What would that be?
48.
48. Good. Okay. So definitely understand that. So the concern I'm having is, I guess we just got to do a few more examples. What is 1 2/3 converted to an improper fraction? Take that 3, multiply by the 1, and add 2.
Um, 5,
Okay. On top, and what goes on the bottom?
so 3.
Okay. And let's say I wanted you to subtract 2/3. Do we have to convert this one on the right? Is it a mixed number?
Um, yes.
So let's
No.
go back. Let's go back and look at the definition of a mixed number. So mixed numbers, they have both a whole number and a fraction. Okay. Whole number and a fraction. Does this have a whole number in front?
No.
So it's good as is. All right. What is 5/3 minus 2/3?
3/3.
3/3. Yeah. Good. Okay, let's try another one here. Let's go 5 3/4.
Give me a drink.
Oh, okay. Let me know when you're back.
Okay. And then
Okay. So we're going to do 5 3/4. So I want you to first convert that to an improper fraction, please.
uh, 23 and 4.
23/4. Good. And let's say we want to subtract 1/2 now. Is that a mixed number?
No.
No, it is not. Actually, let me make it 1/3 because that'll no, let's not do that. Let's do 1/2. Okay. All right. Now, are you able to subtract these the way they're written?
No.
No, they need to both have the same denominator. Do you remember from class how to make these the same denominator? Can you share anything with me?
Uh, you should do, they subtract it.
But the bottoms aren't the same. So you can't subtract them unless the bottoms are the same. Okay, so let's change this up here. Let's just say it was 3/4. Okay. Can you subtract them now?
Yes.
Because the bottoms are the same. So what does this become? What is 23/4 minus 3/4?
20, 20/4.
You got it. Very good. Okay. All right, let's do a couple more here. Let's go the other way. Let's start adding 1 5/6 plus 2 1/6. Okay, I want you to first convert each of these to an improper fraction.
They have the answer.
Okay, what is your answer?
I got 3 and 6, 6.
Where did you get, where's the 3 from?
From the 1 plus 2.
Okay, so, oh, I see. So you're doing it differently. Are you adding the whole numbers in class?
Yes.
Okay, that's good to know. That's good to know. I didn't know that. So yes, you can add those, and that's 3. And then you have to take 5/6 and add 1/6. So why can you add those together?
Because it had the same denominator.
Very good. So 5, 6 plus 1, 6 is 1.
Um,
Well, let me back up. It's not 1, it's 6 over 6. Do you agree with that? 5 plus 1 is 6.
yes.
Okay. Now we haven't been talking about this, but what is 6 over 6 reduced to?
1 whole.
1 whole, yeah. Okay, so this is a good time for us to start talking about that. This is 3 plus 1 or 4. Okay, good. So let's try another one here. Now that I understand the way you're doing this, let's go 2 and 7/8 plus 4 and 3/8. So what do you add first?
The whole.
Okay, so what is 2 plus 4?
6.
Okay, and then you have to add the 7/8 plus the 3/8. What does that become?
10/8.
10 over 8. Now, do you remember from class how to reduce this?
No.
Okay, so this is where we got to spend a little bit of time doing something different called reducing fractions. Okay, so let's look at a couple of fractions here together. Let's say it's 2 divided by 4. Okay, so my
Okay.
question to you is there a number that goes into both 2 and 4? Basically, is there a number that divides both of these?
Yes.
What is that number?
You can do 2 times 2 and 4 times 2.
But you're dividing, so it's going
I
to get
mean, you can
small.
do. I mean, you can do 2 divided by 2 and 4 divided by 2.
Okay, what does that become? What is 2 divided by 2? What is 4 divided by 2?
1
1 over.
over 2.
Good, good. Okay, let's try another one here. What is 8 divided by 12? Is there a number that goes into both 8 and 12?
I divide.
Yes.
Yes.
What is that number?
You can do 8 divided by 8, and you can do 12 divided by 8.
Well, they have to both work. 12 is not divisible by 8. So let's start with 2 again. 2 worked really well in the last problem. So what is 8 divided by 2?
16.
You're dividing, getting smaller.
Oh, 4.
Good. What is 12 divided by 2?
6.
Can you get 6? Good. Now, you try it again. Is 4 divisible by 2? Can you divide 4 by 2? And can you divide 6 by 2?
Yes.
Okay, tell me what that is.
So the first one on top is 2.
Good.
And then the bottom one is 3.
Perfect. Okay, let's try another one here. 10 over 16. Can you divide 10 by 2?
Yes.
Okay, what is 10 divided by 2?
5.
How about 16 divided by 2?
8.
Good. All right, let's try a little larger numbers. Let's go 12 over 20. Okay, 12 over 20. Can you divide 12 by 2?
Yes.
Okay, what is 12 divided by 2?
6.
How about 20 divided by 2?
10.
Okay, now you try it again. Can you divide both of these by 2?
Yes.
Okay, what does that result?
2 times 6 is.
You're dividing.
Oh,
Yes, it's
I
3.
meant 2 divided by 2.
So you got to go from left to right. Left to right. So just like when you're reading, you got to go left to right. 6 divided by 2 is 3. So on the bottom here, it's 10 divided by 2. What is 10 divided by 2?
5.
Good. Okay, so you ready to try one?
Yes.
Okay, how about 4/8?
You can do 4 divided by 2 and 8 divided
Okay,
by 2.
so I want you to divide both of those by 2.
I got my answer.
What is your answer?
2, 4. 2/4.
Well, can you divide those again by 2?
Yes.
Okay, so do that again.
Okay. I got my answer.
Okay, what is that?
I got 1/2.
Good, very good. Okay, now let's look at another example here. Let's say your fraction is, what was I thinking of? 6/18. Okay, are these both divisible by 2?
Yes.
Yes, 6 divided by 2 is 3. 18 divided by 2 is 9. Okay, so now does 2 work anymore? Does 2 go into 3 and 9?
No.
No, so we say, oh, we're done trying
Oh
2.
wait, you can do 9. I mean 1. You can do 1.
So 1 goes into every number though. 1 always works, right? Because when you divide by 1, you get back to the same number. So 1 always works, and it does, but it doesn't get you any closer to your answer. You actually go the other direction. What comes after 2?
3.
Yeah, you try 3. What's 3 divided by 3?
1.
Okay, what is 9 divided by 3?
3.
Good. Let's try one more here. Let's go 15 divided by 21. Okay. So try 2. Does 2 go into 15 or 21?
No.
No, because they're both odd. So but does 3 work?
Yes.
Yeah, you can divide both of them by 3. What is 15 divided by 3?
5.
How about 21 divided by 3?
You can do 7.
You got it. Very good. Okay, perfect. All right. Hey, is your mom there? I wanted to, I've got a possible recommendation for you guys. Is she sitting there with you?
Yes.
All right. I'm just going to stop the recording right here.